About all right, so today, if you miss some stuff, you'll never understand it. So let's just make sure we understand that right off the bat. Calculating equilibrium concentrations 2. You have a number 1 already in your notes, but I'll say a couple points that are huge. Understanding the difference between what the question is asking and whether you have to do a rice or not a rice is pretty huge. So let's talk about this. We have this equation. Has anybody ever seen this equation before? Yes. Okay. So the good news is I'm going to use that as kind of a guide of what we're going to be doing. So let's say we have this. And we know that the Kp, all right, equals 1.45 times 10 to the negative 5th at 500 degrees, 500 Kelvin. No, 500 degrees Celsius, I apologize. That's all right, so in an equilibrium mixture of the 3 gases at 500 degrees Celsius, we have the partial pressures as the following. So at equilibrium, see this? This is the key to the question. All right, the 3 gases at 500 degrees Celsius, the partial pressures are H2, 0.928 atm, and that of N2, N2 equals 0.432 atm. All right, so the question asks, what is the partial pressure of NH3 in this equilibrium? In this, I'm going to make sure I highlight this equilibrium. All right, so now I want you to think for a second. I'll put partial pressure. How I would tackle this problem. Somebody give me an idea of what I would do. Yes?
Well, that's the Kp value equals the partial pressure of product over reactants.
Okay?
So couldn't you just rearrange that formula to make the, you're going to make the partial pressure?
All right. I like where you're going. So I'm going to take this. I'm just going to move this for a second. That's good. Just move that down here. All right. Now, what's my initial pressure of N2? I heard it. 0.432. What do I have for H2?
0.928.
What do I have for NH3?
Well, at initial.
So if you're unsure, what do you put? X.
Is that initial or equal?
All right? So at equilibrium, the 3 gases, the partial pressures are this, this, and this. What is the partial pressure of NH3? All right? So in first period, they were saying, oh, you know, we should do a rice and make that 0. Why is it not 0?
It's not initial, it's equilibrium.
All right, this is at equilibrium. All right, you guys are already experts, it seems like. I'm kind of excited about that. All right, so now we can plug and chug. So what I'm going to do is I'm going to take these out. Let me do this real quick, see if I can do this. Oops, not that. Let me just move this down for a minute. Do that, that'd be great. Oh, wait a minute. That's not what I want to do. There we go. I'm just going to do that. See you later. Okay. So, now, how do I solve this? KP. Again, we always have to write our expression. What's our expression, Stephen? I don't know. What's our expression for KP?
It would be the pressure of NH3 squared over the pressure of N2 times the pressure of H2.
All right, let's go ahead and plug in our numbers and or our factors. So we're going to have x squared. All right, I always use parentheses on this because sometimes it could be a 2x or a 3x or a 4x because there's a difference between 2x squared and 2x squared. What's the difference? What's the difference? If it's 2x squared versus 2x squared, what's the difference? What does one equal?
Raising to
4x squared.
One equals 4x squared, the other one is just 2x squared. So if you don't take your value and put it in parentheses, then square it or cube it, you're never going to have the right answer. All right. So I put this here, 0.432 and 0.928 cubed. All right, let's see if you can give me an answer for x. What does x equal? Oh, we got the calculators out. Let's get those calculators out. That's what I'm talking about. Calculator! Here, calculator, 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 calculator. Will, where's your calculator? Will, where's your calculator? Got an answer? Got an answer? What'd you get? Oh. What? All right, turn it on. Let's be a start. Okay. Anybody have a number for me? A number?
5 times 10 to the negative 6.
No.
No,
You
you
gotta
gotta
get
read
rid
it.
of it.
Is that
0.002?
No.
Yeah.
0.002.
2.2 times 10 to the negative 30.
Oh, point oh, yeah, okay. 2, I have.
He was right, he just didn't do it in scientific notation.
Oh, yeah, well, no.
You were right. Just go with it.
All right, now I want you to do a check. Do a proof and show it to your neighbor. Do a proof on this to make sure your answer is right and show your neighbor. Okay. Do a proof. How could you prove your answer is right?
You plug and check.
You have an x value, put the x value in and see if it equals 1.45 times 10 to the negative 5th. Sorry, there's 1.45 times 10 to the negative 5th.
Do it again. Yep. Yeah, I got it.
You got it? I didn't hear any calculator high fives. I still haven't heard a calculator high five. There's one. I heard one now. That's what I'm talking about.
It's an oxygenated yogurt question. No, oxygenated yogurt.
Oh, okay, sure. All right, this is an on your own question. All right, so you should be rocking and rolling on this. All right, let's see if you can get this. Partial pressure PCl5. Now, I'm going to give a status update. This question and the one before are off 2000. Well, one's off 2009, one's off 2008. So you didn't even have to do the rice. And I look at people's answers, they're trying to do rice. You don't have to do the rice all the time. Only sometimes. You have to know what's in the question.
Random bell.
I don't want a fire drill right now, that's for sure.
Oh, my boss does that. I was definitely different
All right, so try that question real quick, sir.
Is the pentachloride a gas also?
Yeah, all gases. Thank you. Thank you, sir. Thank you. Mess that up. That's what I do best. I lock that door. There could be an active shooter in here. Well, I don't know. Maybe what's going on in the house?
5 doors in
There's no possible way to lock all of it.
5.
There's a fire. There's a fire.
You just don't know. Lock this one too. We're gonna have
There are literally 5 doors.
all right. You ain't going nowhere.
Someone made a joke.
Once you get an answer, try to check with your neighbor. While you're doing that, I'm just going to do a little work on this. All right, if you have a quadratic formula equation in your calculator, be ready to use that, because that's where we're going next.
You have your internet, is that what you're saying now?
I have it in my head too. It doesn't matter.
Let us just slide it.
You'll find out in a second. You're excited. You like the quadratic equation. Here we go. Everybody get 1.22? It sounds like you did. All right, somebody tell me when it is. Somebody tell me when it is 5 up.
Are you okay?
Remember that.
All right, so we have those two things. That's going to be at 448 degrees Celsius. Kp, Kc equals 50.5. What are the equilibrium concentrations of H2, I2, and HI? Concentrations of H2, I2, and HI in moles per liter. Anybody have an idea of kind of writing some stuff down, but where would go first with this? Sir.
Write the equation down.
All right, so we could have an equation. That's fine. What is the equation?
H2.
H2 plus I2 gives 2HI.
Why, Will, your voice changed a little bit.
Yeah, I noticed it too.
All right. Now what?
You want to draw the equilibrium?
Oh, yes.
Oh, now.
Now what? Yes, ma'am.
Divide the moles by the liter.
Ah, yes. The biggest mistake every AP student makes. Wants to get right into the rice. Well, you don't know your concentrations. Your concentrations are the most important part. So 1.00 mole H2 divided by 3.00 liters. I think I can do it, but would somebody like to tell me what it is? All right, so we have that. What do I do next, Stephen? I don't know. What do I have to do?
2.000 moles by 2 divided by 3.0000
And what do you get?
0.666.
No.
666.
All right, so we have molar I2. All right, so now we're going to take this information to the next page. And we're going to, my lamp is flashing here. It's wonderful. All right, you have those two numbers? Any questions? What's the most common mistake AP students make? Forgetting to divide by the flask that it's in. All right. So we're going to go ahead and put our equation back down. What was our equation? H2 All right, so I have this. What is my initial concentration of H2? 0 point. What do I have for I2? What do I have for HI? 0. This would be a 0. It's not X. I'll put 0 molar just because I can. All right, change. What's our change going to be? All right, minus 1 or minus what? Minus 1? Not minus 1. Let me ask you this. Do you know how much of this is leaving and this is leaving and how much of this is forming?
Yeah.
Because if you take 1 off of this, well, now I have a negative number. Not possible. Yes? Okay. Minus x plus 2x. All right, so 112 is technically right, Rachel, but it has to be an x. All right, because you don't know how much you're going to lose, and I did this deliberately to make it a 3. I did this whole thing as a 1 liter, so I changed it for you guys special. All right, today. You're welcome. All right, and then I have to do my equilibrium. What is that going to be? Will?
Okay. I messed this up, but
It's online.
I know.
It's online, Will. Will, did you know? Yeah.
Portion.
You had time to study hall, didn't you? If you want to drink study hall.
I didn't have time.
Tim?
23, 30 minus x.
Yeah, that's all we're going to do. Because it's going to lose some. It's going to lose some. All right? What do you think we do for the next one, Will?
0.667.
You're a quick learner. And what about the last one? What do you think we have to do?
0 plus 2x.
All right, what?
2x.
2x. All right, 2x. So now we need to write our KC. What's our KC going to be? Thank you. Say it. Amanda? Okay. On the top. All right, what do I put on the top? 2x squared.
No.
No.
The answer is
Quantity squared.
no. 2x squared. We just talked about this.
Did that. I was using brackets up front. That's why there's a square.
And that equals, what's my KP? 50.5. All right. Well, that's wonderful. So now we got to do a little distribution. All right. So I'm going to have, well, let's see. 4x squared equals, well, I'm going to need some help. What's 50.5? Hold on, sorry. I'll just do this. 50.5, just so you're good, times 0.33 minus x times 0.667 minus x. All I did was cross multiply at this point. I didn't do much more than that. Anybody? I got a couple daunting looks.
Oh, no. No need to worry.
All right, so now, yeah. What would you do first mathematically? What would be the easiest way to go about doing this?
Should be 50.5.
Foil.
Should I FOIL first or distribute this 50.5 to everything?
She'll foil.
So you want me to do this, these two first? That'd probably be a better way to go about it. All right, I'm going to need your help. I didn't use those numbers. All right, we're going to move it over to the next screen. All right, so 4x squared equals, somebody help me out. 50.5 times 0.222.
Yeah.
All right. Minus x is correct. You get like 0.99 or something, right?
0.33. No. It's first outer.
2/3 and 1/3.
1/3.
Okay, so when you do that, it ends up like this.
Oh, yeah.
And then that was
Yeah.
negative 1x.
Plus what?
So we just skip that part.
All right, check it out. See if you can get that. I can go over it if you want me to break it down. Nobody's giving me a head bob on that. Okay, now let's distribute out the 50.5. Well, I know I got, let's see, 50. I'm going to do it this way. X squared minus 50.5x. And then plus what? I don't know. 11.211. That's it. All right. Now, what would I do at this point? I have to set it equal to 0. How can I do that?
Subtract.
4x squared.
Ah, yes, I'm going to subtract 4x squared. That's the easiest way to go about it. Now, we have to put it into the quadratic equation. Does anybody know what that is? Go ahead.
Negative b plus or minus the square root of b squared minus 4ac over 2a.
Okay. All right, so you should have hopefully a program on your calculator where you can just plug in and give me the values. Anybody have that on their calculator?
No, but
I
you put it on the
used to
calculator.
stack these on my
I don't know how to do it. I just know how to do it. Yes?
When you have the original, like 2x squared over, like whatever on the bottom equals 50.5, could you just graph those on your calculator and find out the answer?
Yes, you could. All right, I'm going to tell you a story after our other OEF problem. So just bear with me one second. Tim, did you have two values for me?
Yeah.
What do you have?
0.775
Uh-huh.
and 0.311.
Okay, so now you need to determine what value does not count. What?
Oh,
0.775.
Why?
Because you
You
can't
gotta subtract
subtract
0.775 from 0.333 would make it negative.
You can have a negative concentration. All right, so this one's going to be gone, and I'll show you that on the next slide. This is gone, but I'll show you why. All right, so if I plug this in over here, and my original was, let's see, H2, concentration of H2 is, what, 0.33? Minus X. So at this point, if you didn't know which one it was, you got your two values. Your first value was 0.775? Yeah? Or 0.311. Well, you look at those, and which two could you use to get an answer? Which one do you use to get an answer? Can't have a negative concentration. All right, so this is the only acceptable one for you to use. So I'm going to just plop it in right there. All right, and you can watch my magic. See that? See that? Look at that. All right. And when I do that, I get 0.022. All right? I have to do the other two as well. I can't just not do the other two. 0.667 minus 0.311. No matter what, you cannot change mid-path and start using 0.775. We're not doing that. All right, when I do that, what do I get? I get a 6, I get a 5, and I get a 3. 0.356. Am I done?
No.
I have to do the concentration of HI. 2 times X, which equals 2 times. Now, you could check your answer. How could you check your answer? Plug it back in to see if it equals your Kc value. All right, slow me down if you need to. This is laying our foundation for the higher level titration problems and the higher level equilibrium problems. Let me pause 10 seconds for station identification.